Hello everybody, my name is Josh. I was a computer science examiner for multiple exam boards, head of computer science in UK based schools, and I run a tutoring business. This last lesson is just before the paper 2 OCR exam, and I wanted to get this out because you know we've got the weekend, we've got the Monday until paper 2. And if the only thing that you see is this video, I wanted it to be something that could potentially get you maybe a grade higher. Let me explain why I think it could potentially get you a grade higher. One of the things that is going to be the easiest thing for you to learn, right, is keywords. If learning programming and everything, okay, of course that's going to be important. But think about, you've only got a limited amount of time. That is your finite resource, and it is a very finite resource at this moment in time. Is being able to is where you're going to put your revision, and that can determine what grade you can get, and you can still get a better grade at this point, even this late on. And the way that I see it is, you could apply yourself and work 3 hours and try and get really understand, for example, the ins and outs of recursion, or maybe even more time than that, but let's just say 3 hours for argument's sake. This is going to differ per person and everything, I know. Or what you could do is you could go through and look at all of the keywords and memorize the definitions. So recursion could be up to 8 marks. Knowing every single keyword on the OCR past paper could be as many as 30 marks. But if you apply the same amount of time to get it, it makes way more sense to try and get the 30 marks and the 8 marks. I'm trying to, those numbers might not be exactly correct in there, but the point still stands that there's a lot of marks that you can just get from simply knowing definitions on the OCR paper to just go to being able to program. And I'm not saying completely neglect the programming, but I'm just saying that if you put a lot of your sort of resource of being able to revise into learning those definitions, that's going to be a better use of time. Now, this is so important. Make sure that your keyword definitions are exactly the same as mine. What I've done is I've lifted these up I've got them from mark schemes. I've got them from my own experience of going through all of these things. What students sometimes think to themselves is they think, "Oh, I wrote it about the same, so that will get me the marks." On what I've seen from a lot of students when they think that is that quite often that they don't. So exact wording, and get it and put these on a flashcard. Practice them until you can remember the definition exactly, and then you'll be all good. Okay, so anyway, let's go through these videos. This is going to cover a lot of different topics. As I said, I'm sure that there's maybe the odd keyword that I've missed, but this will put you in a really good place to be able to revise. So this was all of the algorithms and computational thinking keywords in here. So abstraction, the idea to be able to ignore unnecessary details and focus on the important parts of the problem. Decomposition, breaking a large problem down into smaller problems. Concurrent processing or concurrent thinking is the different cores doing different jobs at the same time, e.g. pipelining is an example of this. Concurrent is just, if it ever talks about anything to do with things doing it concurrently, it's all to do with things happening at the same time, things happening simultaneously. Good practice of writing code, having all inputs, outputs, and preconditions mapped out, and then variable names that follow conventions. There's just 2 things there. The question will simply just be, what's good practice for writing code, and then you've got those in there. Problem recognition, simulate the system so you do not have to test on a real one. It's the idea of creating a simulation of the problem. They sometimes say, like, why would you need to do this? Why would you need to use problem recognition? It's because if you were to damage the system on a real one, if you were and you did it on the real one, it could cost you, time for the system being down, whatever. So it's better to simulate it on a different system where it doesn't necessarily matter so much if you break it or cause any issues. Benefits of modularization and planning ahead. They all kind of go into the same things. When in doubt, just talk about the ability to be able to reuse code that you know that is going to work, and it is also going to be tested so many times because the code has been written by experts or it's been used a lots of times so that you know that the program is going to work better. In turn, speeding up development time. What is the difference by dynamic and static? So dynamic means that the size can grow whilst static data structure is fixed. Mutable and immutable. Some people find it difficult to understand the difference between what the difference is between mutable and static. Mutable and dynamic, and immutable and static. So the idea is mutable and immutable data structures cannot so immutable ones cannot change during runtime. Mutable can. Whilst a static data structure, you would set the size to 10 and it can go from 0 to 10 during runtime, but it cannot exceed 10. And I think that's probably the best description I can give. I did a whole lesson on the different data structures. So again, if you need to do a little bit of revision on the different data structures, please do check that video out. The advantages of dynamic data structures and advantages of static data structures. Advantages of dynamic data structures is that you don't need to know the preset amount of items because it will be able to just grow infinitely until the memory allows, and it's easier to adapt to updates in the system. So what that means is let's say that a computer system, it starts off and they have an idea that they want the company to have, 1,000 people in there, and then for whatever happens that the company gets really popular, or the social network or whatever program it is, then it goes up to 1 million. Well, if you've got dynamic data structures, it doesn't really matter if it grows that large. I mean, they'll probably need to change other parts of the system, but if it was a static data structure, they would have to update all of those static data structures because they're not made to work with that number of people. It just means that you've got slack in the system, which can essentially compensate for that. Static data structure is it's going to save memory, and this is going to be good for if you've got limited hardware capacities. And it also forces you to plan your code much better and make sure that you really fully understand it and make it as efficient as possible. Just quickly going through the sorts. So quick sorts on this one, which I think is probably the most challenging one to understand, is this idea of picking a pivot. I got the descriptions of this one all from a mark scheme where they asked you to perform a quick sort. Pick a pivot. So generally what I always say is try and go for the value that is going to be in the middle, and then it makes it a lot easier. You've got 56 here, and then you create a sublist where you go through each of them, and every value smaller than it goes to the left of the 56, and then you've got every value to the right of it in the next sublist, which is larger than it. And then you pick a new pivot again if it's roughly in the middle. Then what you do is then you put everything to the left if it's smaller, everything right to if it's larger, and then just keep repeating that process until you've either got 0 or 1 items in there. Now, one thing that should be worth saying is, so that's a visual representation of it. So pivot, smaller, bigger, new pivot, smaller, bigger. For this one, if it was larger, it would be over here. And then you just keep doing that process. Let's say, though, I picked 81 as the pivot and 65 as the pivot. You would still be able to get all of the marks on this one, even not talking about this, which is why I'm kind of leaving it. I left it out actually on the other quick sort one, but I just thought I'd mention this anyway. Let's say that 81 and 65 are have been swapped around, so I picked that as the pivot there and that one there. You have pointers checking to see whether this value is greater than this value, and then what will happen is they'll swap. But generally, if you have a look on here, this was a 5-mark question, and you don't even need to access all of the marks on this one. You can just go through, choose the pivot, compare the items, put items less than the pivot into the left sublist, put items in the right into the right sublist if they're larger. Choose a pivot for each sublist. Once you've done all of that, you've got every single one of the marks. So I just thought I'd make a quick note of that, just in case it asks you to. But there's quicksort, binary search, adds one onto the total number of items, then divides by 2 to try and find it, and splits it. Asks, is it smaller or less than this item? If it's in this case, we're looking for Mo, so it's going to discard everything less than Lara, and then it just keeps repeating that process until it finds Mo. This is the description for it. I'd make a flashcard on this. Linear search. It's still and if you wanted the code as well, people, I did a video for all of the searches, so please check that video out if you need all of the code. That might be a good thing to get down as well, but this is just a quick going over of everything. Linear search, it starts with the very first value, compares it to the one that you're looking for. If it's in the list, it says item in list, and it's the one that you're looking for. If not, it's going to move on to the next one and repeat this process until it goes all the way to the end. Generally, very, very large lists that are ordered, you're going to use binary searches. To work out the total number of searches for a binary search is you do 2 to the power n, the number of searches. So if it's 16, 2 to the power 4, and then you just add 1 on to 4, so it would take a maximum of 5 searches. Linear is good if it's small and unordered. Bubble sort, it starts with the leftmost item, and then what it'll do is it'll work its way along. So leftmost item is 9 bigger than 5, swap it over, 9 bigger than 4, 9 bigger than 15, and then no. This is a point where some people mess up because what they think is that they need to go back to the start. Don't go back to the start. What you do is you keep going this way. So you can go 15 bigger than 3, 15 bigger than 8, 15 bigger than 11, and once you've done all of that, 15 should be sorted. The biggest item should be sorted, and then after each pass you've got the next biggest item. And as you can see, a hugely inefficient way of sorting. So that's a thing that so things that you need to know for bubble sort is just how it generally works, and that it's a very, very inefficient search, which I'm going to show you the big O notations in a second. Insertion sort is just like placing a deck of cards into order. So you start with 9, that's now sorted. 5, that's now sorted, and you just put it into position as you see the card, and that's it. So it's going to take so say you've got a certain number of items, it's going to take that number of items to sort it. And that one there. Merge sort is where you split them all up into, so keep splitting them up. This is the description here if you need to take a screenshot, or if you're going to make a flashcard of it. Then what you're going to do is then you're going to split them up, and then you just end up placing them all back together. Big point on this one, where I see a lot of people messing up, is what they'll do is they'll merge them, then sort. Can you see that the merging and the sorting happens at the same time? And I know that you're probably thinking that's a really weird thing to get hung up on. I don't know why, but it's just when I was examining this, that was a big distinction that we had to make. And people that sort of merged them, and then they put the 2 and the 11 and then sorted them, didn't get the mark. So it happens all at the same time, and then they merge them, and then as you can see they're sorted. Okay, so they just keep merging them back together until they're there. These are the time complexities for the different ones. What you can do is you can use this to, if you get a longer style question, you could use the average time complexity for that one. And just if a student was saying to me, had to make a case of which sort to use in a particular situation, you could say this is the average time complexity for bubble sort. It's a very inefficient search because of this. Insertion sort is this. Merge sort, quick sort have the same average time complexity. And then if you brought in this point up here, that merge sorts are better for larger lists and quick sorts are better for shorter lists, I think there's nothing else I can do but give you a big 12 marks on that one if it was a 12 marker or a 9 marker. Okay, so yeah, I'll get all of those down. Going on to functions and parameters. So functions and parameters and procedures, is just a topic. And I have seen a question which is just a 1 marker. What's the difference between a function and a procedure? A function returns a value, procedure does not. I've seen another one where it just said to you about parameters and how many parameters a particular function or subroutine had. And all you had to do is you just had to count them. So that's got 2. Recursion. Now, a recursion is a function which calls itself. So simple description, 1 marker. Another one which is going into how to, like, what are the advantages and disadvantages, or what are the differences with recursion and iteration, because technically with most things that you can do with recursion you can also do with iteration. So I just thought this was, I got this from a mark scheme, and I just thought this was a really good point here, which is like, what are the differences, what are the advantages, because you can play them off in both ways. So recursion uses more memory, disadvantage. Iteration uses less memory, advantage. Then you've got recursion can express the program more elegantly, or essentially that what that is you can do it in less lines of code than in iteration. So advantage for recursion, disadvantage for iteration. So I'd make a note of that. I think that's going to be a really, I think that's going to be really good for if you get any questions to do with the recursion and all that kind of stuff. Passing by val and by ref. So the idea of by val is this is something that you can do with a subroutine, and it is simply, they could ask you a question like, what is the difference between passing by val and by ref? By val means that it makes a copy and then you can only edit it during the subroutine. By ref is where it lets you interact with the actual data and change in the memory location. So in Python, that's the only one that we actually use, which is by ref. So you can physically change the actual data while value makes a copy of it. Okay. Local and global variables. So local variables are variables that can only be used in a specific routine, while the global variables are ones that can be used across the whole program, and that's something called scope. So what scope it has is based on whether it's local or global, and what that and then that has certain connotations which are either good or bad. So local variables are generally, it's good because code is more easily to be reused. And it's easier to debug because you're not having to check across the whole program to find where the errors are, because you know if it's happening in one subroutine, it can only be in those local variables. Probably the only, one of the advantages, I should say, for global variables is that you can easily edit data and use it across a whole program very easily. Maintainable code, which is just about what you can do to kind of make code easier to read, easier for people to pick up, is write comments, use subroutines, give appropriate variable names, and indentation. And they might ask you to give an example of how to do those. So just, using an appropriate variable name, or using how to put comments in and that kind of stuff. The A-star algorithm. So I did do one on the pathfinding algorithms about how they actually work, but this is just some of the knowledge-based questions that you could get. So this is the similarities with Dijkstra's. Finds the shortest path, and so that's one of those the ones in there. The differences, though, it uses this thing called heuristics, and it sometimes just asks you, like, describe what a heuristic is. It's a best estimate to shorten the amount of searches to find a solution. And what it allows you to do is that it's not going to check every single possibility like Dijkstra's to find the shortest path, because that could take a very long time. It just it uses a heuristic to be able to go and find a particular location. The integrated development environment is where you could potentially get some questions where it's asking you about how that could be used to solve syntax errors and logic errors. So the integrated development environment is like Replit, or where you can write some code. So the way that they distinguish between this is the IDE tools are syntax coloring and auto-completion, which could be to stop syntax errors from happening. And then during runtime in logic errors, breakpoints and variable watch windows are the things which stop you from getting those errors happening in the actual while runtime is happening. Now, just going through a few of the keywords on OOP. So we've got a class is a blueprint for an object. And essentially what this does is this allows you to create objects from this. You can see what properties it's going to be having, what actions that your object can take. So attributes, so methods are the actions that your object can take, and the properties are going to be the different attributes that your object is going to have. The fact that they're set to public and private. So normally methods are set to public. Private, that is going to be the attributes. This is because the fundamentals of objects is that you should only be really able to change the attributes with the methods. Encapsulation, which is just could be a simple warm marker, is the idea that it wraps the attributes and methods in a class definition, hiding details of the implementation from the user. For example, when you use like .random to create a random number, do some whatever it might be that you're using it for, you don't have to have the fundamental knowledge of how it works. You can just type it in, and that's hidden from us. Creating a new object or instantiated, which instantiated just means to create an object. It's this idea that these two work in tandem. I know that technically this isn't what it is, but I was just trying to explain it to some of my students in a way that they would understand. Like in a function where you have to define the function, and then you can call the function, and then you can use it. So by defining it, it is this part. Calling it, as I say, calling it. I know it's not technically not it, but these two work in tandem. You use this, which is the constructor class, the constructor, and then you've got your class, and then what you can do is then create the objects from it. Inheritance is where that you can get so what you can do is you can get a subclass of the superclass, and the key definition on inheritance is it inherits all attributes and methods of the superclass and has some of its own attributes and methods. Polymorphism is that in this class hierarchy is that you can actually have some of the methods which are going to behave differently within each class. This works through overriding, so these working together to make sure that you get the marks on this keyword. They use the same identifier, and you can redefine them or extend them or do whatever you need to do. General advantages of this is it's going to have an extensive planning phase for better design. You've got a really good framework of code libraries, so you've got tested. They're all tested so that there shouldn't be too many errors in there. Software maintenance is easy because it's very rigid. So yeah, just get a few of those down. I would say maybe 3 is all you need to be able to get the marks on that. Now, that is a lot of keywords there, which can essentially push you up a whole grade. I think, there's loads of marks there. There's probably, as many as 20 marks there. 20 marks is probably two grades if you can remember all of those. But I'm sure there's probably a few of those that you knew. But if you're pulling a few of those together, then you're going to be getting those nice high grades. Hope revision goes well, people. Give me a message how things are going. Best of luck. Hope it goes well. I'll speak to you soon.